Hello students, in this session let us continue the discussion with respect to the how the traffic volume data has been represented. Along with that we'll move on to the next type of this study, that is the spot speed study. So first we'll be discussing upon the representation of the traffic volume data. So as we already discussed upon how the data will be collected. So what data we collect in traffic volume studies, so that will be represented in three parameters. The first will be average annual data. The second is the that will be annual data in represented in terms of vehicles per year. Annual average daily traffic or AADT represented in terms of vehicles per day. The next is the hourly flow represented in terms of vehicles per hour. Okay, so first is the how do we collect the average daily traffic. So when you have to get the details about the average daily traffic or ADT, so here the traffic volume count has to be carried out for only few days, for example 3 to 7 days. Okay, so the average of daily traffic is obtained as and that will be used as the average daily traffic. Okay, so second is the, so here what is as the name here itself indicates, we need average daily traffic. For example, we have seven days in a week, 7 days in a week. So instead of conducting the entire survey, the survey has to be conducted to on this entire 7 days. Note down what is the number of vehicles each and every day. Monday, what is the number of vehicles are there? Tuesday, what is the number of vehicles? Each and every day, note down what is the number of vehicles. So total number divided by 7. Take the average of it. If you conduct the survey for 3 days, total of 3 days divided by 3 will gives you the average daily traffic. Okay, so this will be represented in terms of vehicles per day. Second is the average annual average daily traffic. So we have name in here annual. So when it comes, as soon as it comes to annual, we need to conduct the survey for 365 days. So 365 data are collected divided by, so total number of vehicles on entire year divided by 365, that will gives you what is the average traffic volume every day. So here also that will be represented in terms of vehicles per day. So next is the hourly flow. So when you want to have a hourly flow, usually we are concerned more about the peak hour traffic. So conduct a survey for 24 hours continuously. What is the total number of vehicles for 24 hours divided by 24? That will give you the number of vehicles per hour. So like this, what data you have collected, that will be either represented in terms of ADT, AADT, or in terms of the hourly volume. So but when we design for any traffic related facilities, the one which has been commonly used is the data on average annual daily traffic. So that data has to be taken for the design of any facilities. But the thing is, it may not possible to have the details about the 360. If you cannot wait for the 1 year to collect the details, you can go adopt ADT with the help of some of the correction factors. So now how these corrections be applied. So we have the correction factors or adjustment factors. So when you have the adjustment factors, so here what we have to do is, if it is not possible for you to conduct the data, continuous data, okay, at each and every point, what we have to do is what data we have collected, that has to be compared with the data collecting at the control count station. So what is this control station? We are comparing the data with control station. So control stations are the points where you will record the continuous data, the data with respect to the 365 into 24 hours data will be available at such control stations point. Okay, so now if you conduct in any particular place, for example in your place where the study has to be conducted, If it is not possible for you to take the details for the entire year, so what we will do, we will conduct the survey for the required period, and then adjustment factors will be applied with respect to these control stations. Okay, so now we have the three main adjustment factors. So first is the daily factor. First adjustment is the daily factor. So what is this? So we have to take is 7-day average for 24 hours divided by 24 hours count on a particular day. So what is it indicates in the control station, we will have the 7-day data. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. Okay, so you'll have the details about all the 7 days. Okay, so take the average of all the 7 days that will be there on the numerator. Okay, 7-day average for 24 hours continuous data divided by 24-day count on the any one particular day. So that one particular day, that can be the Monday or Tuesday, anything like midweek. Okay, so numerator average of all the day divided by what is the count on Wednesday. So that will gives you the daily factor. Okay, so but if you are conducting the survey on Sunday, take what is the detail on Sunday. Okay, like that you can have the adjustment factor. Similarly, weekly factor. So when you take the weekly factor, so what we have to do is we should have the details about the entire all the 12 months. 12 months detail divided by, so average of 24-hour traffic for the 4 weeks in a month, in a month for 4 weeks, all the 4 weeks. So note down what is the total number of vehicles. So 4 weeks total number of vehicles divided by 4. So okay, that will be there on the particular week. And when you want to apply the correction factor, for example, you have conducted your survey on the second week. So what is the traffic count on the second week? That will comes to the denominator. And the next is the seasonal factor. So seasonal factor in a year. So what we have to do is for entire 24 months, what is the total number of vehicles divided by 24-hour count on a specific month. For example, I have conducted my survey on Jan. What is the number of vehicles in the Jan month? That has to be taken in the denominator. So like this, what data you have collected, that has to be compared with the continuous data which has been recorded in the control station. So once these adjustments factors have been calculated, and then you have to go for calculating the value of ADT, AADT. So ADT can be calculated as total traffic count, what you have got, into daily factor into the seasonal factor. And then AADT is calculated as ADT into daily factor into seasonal factor into the weekly factor. So sorry, AADT can be calculated. ADT value what you have got earlier into daily factor, weekly factor and the seasonal factor. So like this, what traffic data we have collected from the field, that can be suitably adjusted using the control station data. So and next is design hourly traffic volume. So now we have conducted the survey, we have represented. Now we have I even told you the what is the traffic volume. Sometimes in the traffic, when you design some of the facilities, we will take what is the design hourly traffic. For example, in cities like Bangalore, okay, so the traffic is not constant throughout the day. So due some of peak hours time, traffic will be high, and off peak hours time, the traffic will be very less for you. So in such cases, which traffic volume we have to take? Either the traffic volume during the peak hours or traffic volume during off-peak hours. So which one we have to take? So if you design the facilities for the peak hours, so what will happen, that peak hour traffic may go only for the certain duration in a day. Okay, so usually if you design your facility for peak hour traffic, what will happen, it will not be economical for you. And if you design it for the off-peak hours, what will happen, the facilities what you constructed will be inadequate during the peak hours. So now we have a confusion which traffic has to be taken for the design purpose. So to answer for that, we have it with respect to the design hourly traffic volume. The traffic volume which is used for the design purpose, that we call it as the design hourly traffic volume. So to determine that, you have to plot a graph between hourly traffic volume, so hourly traffic volume percentage of ADT in the x-axis, and also versus the number of hours in a year that the traffic volume was exceeded, maybe the exceeded the capacity. So each and every road will be intended to carry some of the capacity. For example, your road will be having a capacity to carry vehicles 300 vehicles per hour. Okay, each and every category of the vehicles will have its own capacity. So sometime during the peak hours, these vehicles, the number of vehicles will exceed the capacity. Okay, so now how many such hours the traffic volume exceeded its capacity, that is noted down here in the x-axis. Okay, so we are plotting to find out the design hourly traffic volume. We are plotting a graph versus the ADT on the y-axis and taking the number of hours that are exceeding the capacity on the x-axis. Okay, so now here with respect to that, you need to plot the 30th hour. So usually the design traffic volume, we will take 30th hourly traffic volume as design traffic. So what is this 30th hourly volume? So 30th highest hourly volume is an hourly traffic that will be reached only 30 times. Okay, so this particular traffic will be reached only 30 times in an year, or which will exceed 29 times in the year. Okay, and then on all other day the traffic volume will be less than this value. Okay, so this 30th hourly volume will be taken as the design hourly traffic volume, and that will be used for the construction of various facilities in the traffic for the traffic operations. So next we have another important topic with respect to the traffic volume, that is the PCU. PCUs are nothing but the passenger car unit. So we are already told you the when we will conduct the classified volume count. So when you construct a classified volume count, we will be taking the count of number of vehicles under each and every category. How many two-wheelers, three-wheelers, each vehicles will be considered. So but thing is, when you represent, we have to convert all into the single unit. Okay, so because what is the load that we are having on the car, that cannot be equivalent to what we have in the two-wheelers, and also this car cannot be equivalent to the LCVs or even any other buses. Okay, so each and every vehicles will carry its own loading. Okay, so now here what we have to do is, once the classified volume count is done, we are converting all the vehicles into the one single parameter. Okay, so now in India, that we will convert all into the one standard vehicle. Okay, in India we are considering the passenger car as the standard vehicle. So all vehicles will be converted into the one vehicle, one standard vehicle. So in India we are using the car as a standard vehicles. So that why the representation we call it as the passenger car unit. Okay, so now how we can convert. So we have the equivalency factor for each and every car. For category of the vehicles, we have equivalency factor. So using that equivalency factors, you can convert all the vehicles into the one single unit with respect to the passenger car. So those equivalency factors are given by IRC. So IRC stand for Indian Road Congress. So Indian Road Congress will gives you all the specification with respect to the standards for the design of traffic facilities. I ask Indian Road Congress. So I've already given you the information related to the Indian Road Congress. So as per the IRC, the motorcycle equivalency factor is 0.5. So that indicates that your one car is equivalent to two motorcycles. So for passenger car, it is one. So because that is our standard vehicle. And also agricultural unit, so one agricultural unit, one agricultural unit is equivalent to 1.5 times the car. Like that, if you have a truck or buses, equivalency factor is 3, and for trailer or agricultural unit, the equivalency factors will be 5. Okay, so like that, we have to convert all the vehicles into the one single category. So how do you get the PCU values? I'll just take up one simple example. For example, I have number of two-wheelers as we will done the survey, and I have got the number of two-wheelers as 20, car 15 are there, and I have some LCV vehicles, some 3 LCVs are there, 6 buses, and 1 truck is there. So now I have to convert all the values into the PCU. So how to convert? My motor two-wheeler is 20 number. Multiply that with the equivalency factor. Equivalency factor is 0.5 plus what is the car? Car number is 15. 15 into equivalency factor is 1 plus LCVs. We have counted 3 LCVs, 3 into 3.0 plus buses 6 into equivalency factor is, this is 1.5 plus, and also the truck is, number of truck is 1 into 4.5. So all these you count, what you get, that will be in terms of PCU, number of vehicles in terms of passenger car unit. Okay, so ultimately what are the data that you have collected in the traffic volume studies, that will be converted into the PCU. So this is one of the important question with respect to the examination. They'll ask, write a note on passenger car units. So related to the traffic volume studies. So now the aspect is move on to the next studies, that is the speed studies. Okay, so we have now got the informations about the number of vehicles. So next is we should obtain what is the details about the speed of the vehicle. So when we have the speed, we have the various speeds. Okay, so first we'll define the different types of speed that is required for us. The first one is the spot speed. Okay, what is a spot speed? Spot speed is nothing but an instantaneous speed of a vehicle at a specified location. Okay, so this is my road stretch. Okay, within that road stretch, I have considered one point. So this is my road. At this point, what is the speed of the vehicle at this point? That is considered as the spot speed. So I have a road stretch. Within the road stretch, we have one point which you have chosen. So at this point, what is the speed of the vehicles? That is called as the spot speed. The second one is the average speed. Okay, so now the second speed, average speed, I have 2 points, point A and point B. Okay, so now I know what is the distance between these two. The distance between, we have 2 kilometers road. So you first note down what is the time required for you to reach from point A to point B. So for example, I have got 30 minutes. So now what is the relationship between the speed, distance and the travel? The speed V can be calculated as distance divided by time taken. We have 2 kilometers, 2 divided by 2000 divided by, I'll convert it into the meter, divided by 30. So, okay, so 30 into 3.6 converting into the hours. So we will get what is, okay, if you have details about the time and the speed, we can find out what is the speed of the vehicle. So now here, when you take the average speed, so this 30 minutes are including the delays. Okay, sometimes there may be signals here, or your vehicles might have stopped for any reason. Okay, for totally, what is the speed achieved, the average speed achieved for you when between to reach one point to other point, that we call it as the average speed. And we have one more thing, that is the running speed. Okay, so running speed is nothing but the what is the speed achieved by your vehicle during the motion. Okay, so for example, out of this 30 minutes, I have 5 minutes delay. Okay, so 5 minutes in this delay time, your vehicle, you are expected to stop your vehicle at these delays. Okay, but what is the actual time at which your vehicle is on? That is only for 25 minutes. So now here we will, when you calculate the running speed, we will exclude the delay and you calculate the speed. Okay, so that will gives you the running speed. So when you conduct the speed studies, so first thing is we will be determine what is the spot speed, and we will be determining what is the average speed, and the third we will be determining about the speed. And next is the we have the okay journey speed. So that is the total distance divided by total journey time. So I've already explained you this. So we have two types of traffic studies that are involved. The first one is the spot speed study. The second one is the speed and delay studies. So when we conduct the spot speed studies, we'll get the details about the spot speed data, and when you do the speed and delay studies, we will get the details about the journey speed, and as well as the running speed details can be collected here with the help of the speed and delay studies. Okay, so we'll take up one studies. First, we'll move on discussing with the spot. And before moving to the procedure of the study, so we will understand what is then objectives of conducting these speed studies. So with the help of these studies, the speed value V usually represented in the terms of kilometers per hour, kmph. So that will be used for the geometric designs of the road, and we can also use it for the regulation and the traffic control operation. Okay, traffic control operation, for example, the speed limits, to restrict any speed limits and to have a control on the speed of the vehicles on into particular road stretch. You can use those data, and we can also analyze the cause for an accident. If the accidents have occurred because of the overspeeding, we can analyze that, and also we can get the relationship between the speed and the accidents, and we can also study the before and after improvements. So what it is, I have a road stretch, I have an intersection here. Okay, so first here to reach between point A to point B, note down what is the speed that you have achieved before achieved. Okay, so but and we have noticed that at this particular intersection there is lot of delay that is caused. So now instead of that intersection, you construct your bypass, or you construct a flyover here. Okay, so after constructing the flyover, note down again what is the speed that is achieved to reach from point A to the point B. Okay, compare both the speed. So if there is any changes between the speed before after improvement, what is an improvement is the construction of flyover. After constructing the flyover, if there is any improvement in the change, so that it says that the what implementation you have done, that is justified. So like that, comparing the speed before and after the improvement, so you can justify the any work that has been done. And also for if any congestions are there in particular road section, that can be identified, and you can relate that to the capacity, and if required, suitable improvement measures can be taken with respect to that. So next is we'll move on to the first speed study, that is the spot speed studies. So what is the spot speed? It is a instantaneous time. So I have a road stretch. At this road stretch, I will consider one point. So at this point, what is the speed of the vehicle at this point? So that we will call it as the spot speed. Okay, so there are some of the methods that are available to determine the spot speeds, or direct timing procedure, inoscope, pressure contact tubes, and the short base method. Okay, and we have these all the methods which requires observation has to be taken on time required for the passage. Okay, so we will have this particular, they have 2 points, so we know the relationship, speed is equal to distance divided by time. So we in these first four methods we need to have a distance with data and the time. So what is this distance, ma'am? You are conducting the detail, we are conducting only for one particular point. So point in a sense, if this point, the entire road stretch will be kilometers together. So we are just taking a 1 meter distance. So that will give at this point what is the speed. So if we have 1 meter, what is the distance time taken to cover for 1 meter divided by the time required, distance divided by time. So using those data, you can calculate what is the spot speed. The second speed is we don't require any measurement of distance and time, which will automatically counts the data. That is, the radar speedometers can be used to determine the spot speed data. And the third, we can also use photogrammetric methods to determine the spot speed data. So the first method and the simplest method is direct timing procedure. So it's a very simplest method. What we have to do is we just need two reference point, 1 and 2. So the some of the instruments that is required for you, we require the stop clock. Okay. So when for vehicle passes the first reference point, start the stop clock, and when it passes the second reference point, it's a very simplest method, but disadvantages is the reaction time of the two observers is in. So when you start the these are the two reference points. Stop the clock walk when the vehicle passes the first reference point, and stop it when it passes the second reference point. So we'll be knowing what is the distance between these two reference points. The distance divided by time, you can calculate the spot. So what is that when you start the stop clock? Okay, so you may take the fraction of seconds more to start the stop clock. Similarly, when the vehicle passes the second point, so a few more seconds may be added before, or you may even stop the stop clock earlier. Okay, so that we call it as the reaction time of the two persons are involved here. Okay, so that with the help of there will be a certain error that is caused in the speed measurements. Okay, so what disadvantages we have it in the direct timing procedure, that is overcome in the next, what is the class in detail with the coming classes. Thank you. Picture here, okay, that is the enoscope method. Okay, so scope will